In this lesson, we will look at finding the equation of an exponential function from a table of values. So sometimes we're given a table of values and we are asked to find the equation. In this table, we are going to first find the common ratio. So remember, if a function is linear, we look at the first differences. If the function is quadratic, we look at the second differences, but if the function is an exponential equation, then we are going to find the common ratio. So I'm going to take two numbers and divide by the number preceding it. So 8 divided by 2 would be 4. Then I will take 32 divided by 8, also 4. 128 divided by 32 is 4, and 512 divided by 128 is 4. So by finding this common ratio of 4, this is the base of the exponential function. So all exponential functions are y equals b to the x. So we just found the base. So this table would be y equals 4 to the power x. Now, sometimes we have a number also multiplied by the base, which is our starting value. So we can see that our starting value is 2. So when x is 0, y is 2. So when we put in the values for y, or for x, so when x is 0, I get 4 to the power 0 is 1, but my y value is 2. When I do 4 to the power 1, I get 4, but my y value in the table is 8. If I do 4 to the power 2, I get 16, but my y value is 32. So after we do the exponent, we are multiplying these values by 2. So we get 2, we get 8, and we get 32, which are the numbers in the table. So not only are we using 4 as the base to the exponent, we are also multiplying by 2 because that is our starting value. So the equation of this table would be y equals 2 times 4 to the power x. So common ratio gives you the base, and then you want to look at the starting value, which is 2. So we're going to look at a few questions that are in the guide here. In this question, it wants you to justify whether the table of values given is linear, quadratic, or exponential. So the first thing I would check for might be linear. So remember, if it's linear, the first differences are the same. If it is quadratic, then the second differences will be the same. If it is exponential, it will have a common ratio. So I want to check all three. So I might check linear first. So when I look at this table, I can see that this is increasing by 0.3, 0.6. That's not a 0.6. 0.6. This is going up by 1.2. This is going up by 2.4, and so on. So the first differences are not the same, so it's not linear. Then I might try it again. So this is going up by 0.3. This is going up by 0.6. Second differences are not the same, so I know it's not exponent or quadratic. So then I'm going to try a common ratio. So 0.6 divided by 0.3 is 2. 1.2 divided by 0.6 is 2. And I'll try one more. 2.4 divided by 1.2 is 2. So this has a common ratio of 2, so this one is exponential. Go to the second one. I'm going to do the first differences first. It's going up by 3. it's going up by 3, it's going up by 3, and so on. So this means that since the first differences are the same, it is linear. Okay, let's check this one. Going down by 9, going down by 7, going down by 5, going down by 3, going down by 1, going up by 1. So the first differences are not the same, so I'm going to try the second. Increasing by 2, increasing by 2, increasing by 2. So since the second differences are the same, then I know it is a quadratic function. Okay? So linear first differences are the same, quadratic second, and exponential common ratio. In this question, it wants you to determine the y-intercept, sketch the graph, state the domain and range, and state the equation of the horizontal asymptote for each of the following functions. So you can do this on Desmos if you want to check your answer. So let's just do A. So y equals 3 to the power x. So if I'm going to draw the graph, 3 to the power 0 is 1. 3 to the power 1 is 3. And 3 to the power 2 is 9. So 3, 4, 5, 6, 7, 8, 9. So it looks something like this. So I can always do a table of values. And then I know on this side I will have 1/3, 1/9, 1/27, and so on. So it's going to look like this. So there's my 3 to the x. The y-intercept is the value of x when y is 0. So when x is 0, y is 1. I've done the sketch. The domain we've talked about previously. The domain will be any real number. There are no restrictions. And the range, we know that the range can be any number, but we will not go below 0. So y will always be greater than 0. Now the horizontal asymptote is the line that the curve approaches. That's what a horizontal asymptote is. So in a basic exponential function, this x-axis is your horizontal asymptote. This is the line that the graph is getting close to but does not touch. So we would say the horizontal asymptote is at 0. Y is 0. That's the equation of that line. If we move the graph up and down, that line might change. So I'm going to skip over to, so I've done it. I'm going to skip over to E. So E, y equals 2 to the power x, and then after that we're going to subtract 3. So what does that do to the graph? Well, I'm going to do a table of values. So I'm going to do -2, -1, 0, 1, 2. So 2 to the power 0 minus 3. So that's 1 minus 3 is -2. 2 to the power 1 minus 3 is -1. And 2 to the power 2 is 4 minus 3 is +1. And then we have 2 to the power -1, which is a half. And a half minus 3, 1/2 minus 3 is -2.5, or -7/2. I'll just do it in decimals. So 1/2 minus 3 is -2.5. 1/2 minus 2, so 2 to the -2 is 1/4 minus 3 is going to be -2.75. So what's going to happen is this graph is going to shift down 3. And that's what this does. This, anything that is added or subtracted after you do the exponential function is going to shift the graph up and down. So I have 0, negative 2. Put some numbers here. So I have 0, negative 2. I have 1, negative 1. I have 2 and 1. I have negative 1 and negative 2.5, which is about here, negative 2.75. So you'll notice that now the graph approaches y equals negative 3 instead of 0. So the horizontal asymptote is y equals negative 3, because by subtracting 3 after we do the exponential function, it shifts the whole graph down 3. So the horizontal asymptote is always at 0 unless you have a number added or subtracted that will shift it up and down. So in question D here, that's going to shift up 5. So my horizontal asymptote is going to be at 5 this time. So the y-intercept also changes because it's shifted down. So the horizontal, or the y-intercept's now at 0, negative 2. The domain still stays as any real number. And the range now changes because now I can see the graph is above negative 3. Because again, that horizontal asymptote shifted down 3. So the rest of the graphs you can try on Desmos and see what they look like, or you can make a table of values and find some points and plot them. Okay, in this question you want to match the function with the graph. So a couple of graphs we can eliminate right away because we can see one is a straight line. So this one here is linear. So I want to look in these equations, which equation would be linear. I'm looking for 1x and 1y, so that would be A. So maybe we'll just write the equation here. So y equals 0.5x is a linear equation, and it's the only one there. I don't see any other linear equations. Then I'm going to look at this one. This one is quadratic because it has produced a parabola. So when I'm looking at these equations, I want to see an equation that has x to the power 2, which is C. So those ones are fairly straightforward to identify. The rest of them are all exponential. So remember that graphs that increase, exponential graphs that increase, have a positive base. So the base is greater than 1. And exponential graphs that decrease, go down, have a base that's less than 1, greater than 0. So a fraction or a decimal. So when I'm looking at these graphs, this one and this one have whole number bases. One is 2 and one is 8. So they should be going up to the right. So 3 and 5 are going up to the right. The difference between 2 to the power x and 8 to the power x is that 8 is going to be steeper because 8 is a bigger number. So the bigger the base, the steeper the line. So this one's going to be 8 to the x because it's steeper than this one, which is going to be 2 to the x. So those are the two exponential functions that are increasing, so they have to have a positive base that is greater than 1. The other two are, oh, I put that one in the wrong one. This one is going up, so this one is 2 to the x. The other two are going down. So 4 and 6 are going down, so they will have a base that is a fraction or a decimal. So 0.5, 0.5 are both decimals. So those are going down. The only difference between the two is that f is also multiplied by 2. So if you think about where their y-intercept will be. If it's 0.5 to the x and x is 0, it would have a y-intercept of 1. Whereas if it's 2, 0.5, and we put in 0 for x, now it's 2 times 1, so that would have a y-intercept of 2. So this one has a y-intercept of 1, whereas this one has a y-intercept of 2. So this one's going to be 0.5 to the power x, while this one is going to be 2 times 0.5 to the x. Okay, so just to recap or summarize, exponential functions, graphs of exponential functions, they all have the same shape. So if the base is a positive number, it will be an increasing function. And the base, they're always ab to the x. B will be greater than 1. It will be a positive number greater than 1. If the graph goes down, which means it's a decreasing function, and we have the equation ab to the x, b is going to be less than 1. But greater than 0, it's not going to be negative, but it'll be a number between 0 and 1, which is a fraction or a decimal. The y-intercept of exponential functions is always at 1, unless we stretch it or shift it. The domain is always any real number, and the range is always any real number, and y will always be greater than 0, unless, again, we stretch it or shift it. So maybe we'll move it around, but the basic graph is always any real number greater than 0.